Hello and welcome to AI and Deep Learning for Enterprise, and a meetup all about applied AI. Today we're very lucky to be hosted by the lovely Sivo Tech Junction, and as always sponsored by Daemon Solutions, who are very graciously providing all of the food and drink and paying for this very nice venue. My name is Hugh Evans. I am an organizer at Agile and your host this evening. If you have any issues or need to find anything, please do give me a shout. You probably won't have too much trouble finding me in this room this evening. Would you like to speak at one of these events? We currently run a CFP, so if you're interested in submitting an abstract for a talk, or you have an idea for a workshop or something, then please do give us a shout. We are hosting all sorts of events. You can also find a link to the CFP in the meetup description. We have code of conduct for all of our events. The short version is at Agile we are committed to ensuring a safe and welcoming community for everyone involved. All communications should be professional, in the sense that appropriate for a professional setting. And we treat our hosts and our venues with respect. When I say our hosts, I mean the people who are supporting these venues making that work rather than me. Okay, without further ado, I'll run you very quickly through our agenda for this evening. Up first, we have Ivan, the CTO at Quantly, who's going to be talking about unexpected learnings from deploying LLM products in production. After that, we have Sapnil, who's a project manager at Insife, who's going to be talking about agile project management in the age of AI. And last but not least, Artur, a machine learning engineer at a company that I am not allowed to tell you the name of, is talking about data as an API, a principled data management approach for ML projects. I'm going to quickly jump through these slides. And I'd like to welcome Ivan to the stage. Everyone give Ivan a big hand, please.
As typically I'm preparing slides for clients, I need to keep them professional and do everything correct. Here I don't have to do that, so you can see a lot of random stuff. I'm not a good slide designer, so please ignore everything you see, and hopefully there'll be something fun in there. But anyway, I'm going to talk about, deploying serious LLM-driven applications in enterprise. My background, I'm CTO and co-founder at Quantly, where we build LLM apps for finance. We basically build tools for equity researchers and analysts to do their work better. And we do a lot of things. I'm not going to go through all the details unless you'll have questions and will want to learn more, but please feel free to interrupt and ask if you want. But yeah, we are a small team. We started around 2 years ago now. Yeah, 2022. But we already worked with quite a few funds, and we are helping them actually tame all the complexity of the data that they have internally, both structured data and unstructured data, using LLMs. Now, we see that the market is changing right now. The market is changing quite significantly. When we started, we thought that everyone will be, for example, preferring to use off-the-shelf products. So people would love to just buy something and use it instead of building something in-house. We see that changing. We see that there is a huge fragmentation in terms of tools and tooling that can be used to build internal applications or build large applications, external ones. But also, I think a lot of clients that we spoke to 2 years ago didn't even imagine how much they can reinvent certain things about their business. There were workflows that they thought they could automate. It turned out it's very hard. And there were workflows they didn't even think about. And it turned out it's a good candidate for automation. Now, before we jump into details, I just wanted to make sure we talk about roughly same terminology. This is not something I came up with. This is from, I don't remember the name of the guy, but here's his handle on Twitter. But effectively, there are a few use cases for AI, primarily three. There are GUTs, so basically AGI. Nobody has that yet. OpenAI hasn't finished their launch week, so maybe we'll hear something new, but I doubt it right now. There are interns, so copilots, everything that looks like Copilot and works like Copilot. And there are cogs. There are small automations that you can put in place. You can think about something like Zapier or some bits of code, Lambda functions that you used to build in the past, but that would be LLM enabled now. Well, what we are building is we are building kind of a mix of the last two sections. So on one side, we have an off-the-shelf product that funds can buy they can start using it, they can start making it part of their investment workflow, and that's effectively Copilot. That's a system that helps them do their work better. We are selling the custom LLM tools that are built on top of the same tech base that allows clients not only use the same Copilot that everyone else is using, but also automate their own internal workflows in some pretty cool ways. Well, that was the company. But I think what's more interesting for all of you is not necessarily learn all the things that we've done in terms of marketing and positioning and how we sell our product, but probably the different challenges that we had as we were deploying all these LLM tools with enterprise customers. And there are quite a few of those learnings. I think we'll go through all of them, but again, if you have any questions or comments, please feel free to interrupt at any moment in time, and we can start. And as you can see, yeah, random images, random GIFs, that's going to be the topic of the presentation. So if you go to some conference, enterprise conference, most of them, people will be talking about Llama. They'll be talking about different open source models, how you can deploy them in-house, how you can have data sovereignty and do all of those great things. What we found, even at one conference I was just recently, which was LSEG conference, behind closed doors, the conversation changes completely. Nobody cares whether the model is open source, really. I mean, it's cool. Technical people, myself, we like setting up our own stuff and running our own things. But eventually we're at that stage of life cycle right now of these technologies that nobody really knows all the capabilities and all the new opportunities that will be unlocked. And actually, most of the people that we work with and we talk to, they do prefer just to use off-the-shelf proprietary models. So your Anthropic, your OpenAI. Some clients use Gemini. That's a minority, but the first two are basically 95% of large companies that we work with. And just to be clear, publicly, a lot of them will be talking about deployments of Llama. Internally, we see something very, very different. Just to address something, of course, people were concerned for a while about data privacy and stuff like that. It turned out that it was enough for a lot of these models, especially Anthropic models, to become available via cloud providers. So you can use Anthropic on GCP and you can use Anthropic on AWS. Similarly, you can use OpenAI models on Azure, and that's enough for everyone to be okay with using those models. Before I forget, yeah, probably the couple of important bits why that's important. So yeah, as everyone is just discovering what's really the opportunity that they can unlock with LLMs, the fact that LLMs from these providers get released every couple of months is very huge. You build one integration, you build one system. I think we'll be back in a second. And then every couple of months for free, you get a huge improvement in performance. And that's pretty nice to have. And then cost-wise, they were expensive for a while. Now with prompt caching, actually they become very, very cheap for majority of use cases. We used to calculate on average that queries to our system, which is a pretty complex application with a lot of agents working on every request and stuff like that, they used to cost us around 1.5 pounds per user question, which was completely unsustainable, but something we did for demos and to get customers. Now it's around 5 pence for the same query and roughly the same amount of calls to LLM. Now, however, all of that making our life easier, because integrating with GPT and integrating with Anthropic is something you can do very easily, and then you can just move that integration around. You don't need to host anything. Everything becomes much, much easier, except when you work with large clients, you often need to integrate with internal systems. You need to integrate with those databases. You need to integrate with some internal APIs. You need to do a lot of that legwork when you just deploy your system in there. But that's not where everything stops. Actually, you need to align yourself with the internal lifecycle of systems at that client. For example, right now we have a client where we work with their internal set of APIs and also a database. Now, those APIs right now in active development, they're changing every 3 weeks. They deploy new versions of the API, they add new endpoints, they change their endpoints, and we need to stay up to date with that. And something that we had to build is basically a system that incorporates those changes automatically and makes it as easy as possible to stay up to speed with everything. There are a few levels of complexity. Simple, you just plug into whatever endpoint where they have their Swagger, and if that's enough for your use case, that's it. With databases, it's a bit more complicated, but by now, LLMs became pretty good in terms of introspection. Now the hard one, that's unfortunately, in one case, that's what we had to do. So we are integrating with a client's API that's effectively a front end for a graph database. There is no set schema, there is no set anything basically. There is a graph of some entities, everything else is free for all. Now they have a lot of information about the contents of the database in their Confluence. So we use that Confluence, we just plug into updates that go into Confluence and monitor it for changes. And when there are significant changes, we distill those into additional knowledge for the LLM that allows our system to operate. And if somebody doesn't know, that's a great game. Okay. I don't think this is controversial for anyone. Evaluations are very important. Of course, they're important when you're building something that you will be selling off the shelf. They become even more important when you're trying to build something internally in-house for a client. Now, the reason why they become even more important is because, well, people often don't actually know what they're expecting. They know that they can achieve some improvement with LLMs. They probably have an idea whether it will be in terms of productivity or something else, but they don't really have a good feeling for how to evaluate that impact. So you need to really work with those stakeholders to get that information out of them and put those evals together. And you have to chase them. You have to chase them because people have a lot of stuff on their plate. Actually, yeah, we'll talk about that in a second. And you have to do a lot of legwork at the beginning just to explain to client why that's important, why without that you will not be able to do much with the system, or you'll be able only to achieve some level of performance. And again, speaking from experience, we had another client where the scope of integration was actually quite small. There was just one internal API and one additional, basically, database. We integrated with them in terms of, well, just technical integration. Writing a bit of code to integrate with database was simple. Writing a bit of code to integrate with API was simple. And technically, system was integrated. It was terrible. It couldn't answer any questions. We had to work a lot on getting out of them what are typical scenarios in which LLM was supposed to use which data source, and distill that mostly into prompting, but also into other parameters of the integration. And it becomes, well, really hard to get those stakeholders. Yeah, that's actual footage of stakeholder from our project trying to hide from me, but we found them. And yeah, without going through all the rest, I would leave it at this. There are probably many ways to explain this to people. Something that worked really well for us is a very simple analogy that a lot of people use, but they can think about LLM tools like an employee. When you're hiring a new employee, you need to be able to explain to them what's good and what's not good, what good work looks like, what bad work looks like. That really helped us to squeeze those evals out of our clients. Now, let's get a bit more technical for a second. There are a couple of other learnings that we have, and I want to talk through them. So the first one, yeah, LangChain is nice for experimentation. Llama Index is very interesting for experimentation. We ended up building everything in-house, which most of the time probably is the wrong thing to do. And jury's still out there whether it was right or wrong thing to do for us. But I definitely can say that we had a lot of benefits that came out of that. So first of all, we're working with finance primarily. Finance operates mostly on .NET and Java, at least at that level at which we are working with them. Having system that's native to .NET and Java ecosystem, well, in our case, .NET primarily, we started building some Java stuff recently, actually allowed us to have much better understanding with clients' technical teams. It just makes a lot of conversations flow much easier and much faster. And now, in the end of the day, the problem with LangChain is not that it's just in Python. That's not a problem, that's just one of the parameters. But I don't know how much experience you have working with LangChain in this room. It's the most popular framework for working with LLMs. it's just way too complex for what it does. In its nutshell, in its core, it's a very simple framework. It's pretty thin rubber. The layers of abstractions that they've built over time to try to adapt to all possible use cases and all possible LLMs just made it way too complex. Now, in addition to making somewhat controversial choice of not using open source and available framework, we are not using any of those fancy vector databases. We're using Postgres. We're using Postgres with pgvector for pretty much everything. We're also using, I forgot the extension, but basically, yeah, we're using Postgres for everything. And to be fair, the real #1 reason is that everyone knows, or at least is familiar with Postgres. When we're building things in-house, there's a lot of tooling that allows us to build a system quickly, effectively, monitor it, maintain it, work with it. When we are deploying our system to a client, they're not scared of something new coming into their ecosystem. Most of those clients, they already have Postgres databases running in production. And if they don't, we always can use some sort of Postgres offering from, again, Azure, AWS, or GCP that will run securely in a client's environment. And they will not need to worry about anything because everything is taken care of by a cloud provider. And again, for those who don't know, elephant is a symbol of Postgres. Otherwise, it would be weird to have this. And, well, agent orchestration. I'm kind of diving in some, again, more technical and some more specific topics here for people who are up to speed and know this stuff. Again, please ask questions if you have questions, but for other, if you want something to be explained deeply, also please feel free to ask and I'll do. But effectively, if you read most of the stuff online, people talk about agents in many different ways. One of the most common approaches to agents is that agent is just a combination of a tool and a system prompt. So you have your system prompt of an agent that's a database agent, and it will have tools that allow it to execute SQL queries. And then you'll have something similar for an API and something for another API. Now, what we found is actually real agents are somewhat different. It's your set of tools, system prompts, but also context. So what we do in some parts of our system is that, especially when we're connected to a knowledge base, we can on-demand generate agents for a specific task that needs to be done at that period of time, which is specifically useful for automation use cases, when it's not just a one-off chatbot, but user is working with a system to build an automation, and that agent and everything for an agent is generated right there in time. And by context, I mean literally finding a lot of relevant information that's basically a learning corpus, and then either just putting all of that in the context of the model or synthesizing some sort of a summary that can be used. I'm just gonna skip that for simplicity. I think I have 30 minutes, right? Yeah. I'm just gonna be skipping some stuff there to make it simpler. Now, we have two types of agents. Some of them are probably more familiar to you, the runtime agents, so that's the agents that can be called in runtime. So again, just to make it clear, what's an agent? User asks a question, the main chatbot decides, oh, I have an agent that can help me with finding an answer to that question, and calls that agent to do something. Agent does its thing, returns thing to the chatbot returns something to user. And in runtime, you have all your classical agents like analysis, calculator, search, source attribution, hallucination detection. However, what we found is setup time agents can be extremely powerful. So for things like, for example, database integrations, of course, there is a fair share of work that we do manually when we integrate with customers with complex databases and complex data needs. But with off-the-shelf product, we're still able to integrate with simpler internal data sets by doing just introspection when the configuration is happening. So yeah, basically what our system does, when you install Quantly, when you set up Quantly for the first time as off-the-shelf product, you can link it to your internal database and APIs, and the system will try to do all these things on its own to set up the integration. So in case of database, it will just do a bit of introspection and will try to generate hypotheses based on that introspection of what the data may look like, what the different facts may mean and how they may relate to each other. And then it will go through a set of experiments to try to confirm what's the right explanation or documentation for the database, and then it will store that as a schema that it can use later. And the same happens with API. So LLM tool can have some sort of documentation, or at least even a set of endpoints that belong to API. It will create some hypothesis, make requests, try to validate some of the hypotheses it generated, and then it will end up synthesizing all of that into documentation that can be reused. In terms of other side of things, there is also such thing as personalization. Well, this is very important for us because we work a lot with different funds, primarily hedge funds. Now, every hedge fund has their own process and they have their own approach to how they make decisions. Now, that doesn't mean that it's just about searching through their internal system, doing some sort of RAG application that just searches through information and finds something in the runtime, because very often that framework that they use for decision making is important even at the first step of the bot trying to solve the problem. That's the whole framework that company or fund in this case is using to achieve something. So the system that we set up, the agent that we set up, it goes through that knowledge base of investment memos and internal research documents, and it synthesizes them into a structure, basically curriculum that they could potentially even give to a human to become a good member of the team, that later is embedded with the prompting. This looks like something very simple, but actually it was very fundamental in us building very good service for our fund clients. Now, yeah, I'm just gonna jump through other slides. Yes, we need to deploy on-prem. That's probably not a learning for enterprise. I guess most of you that work with enterprise clients know that's very often the case, but on-prem often means just their own cloud. We use Cabal Deploy just because it's easier than Kubernetes for most of the things that we're doing, and Docker on its own wasn't enough, even though we can deploy via Docker, just via Docker without anything else. But yeah, but in the end of the day, it turned out that running applications on premise is not that hard. So most of my background before building this business was in building SaaS software. And with SaaS software, everything is very straightforward. You control everything, you set up everything. There's not much to worry. Turned out today, there is enough tooling to do a lot of similar things on-prem. Now, I don't want to oversimplify it. There are still challenges, especially with monitoring. Monitoring is much harder, but it's still possible. And yeah, I think I can skip this because that's its own another topic. So what have we learned? There are a couple of these things that we haven't touched really, but I'll focus on the first one. If there is anything that I would highlight as just one most important fact, actually it's nothing out of those complexities that I mentioned, the things about the framework that we used or databases or agents or anything like that. The thing is, OpenAI, Anthropic, they're doing a great job. They're building better and better models. Enterprise, in our experience, in our opinion, is open to using those models. And that's very important because you can experiment with a lot of different use cases. There is a lot of value to unlock in the enterprise market, and I think we're just at the beginning of this journey. Now, again, I'm just going to skip this and skip a bunch of other stuff. Well, basically, we're best in the world, and we're working on some very exciting things for the future with Prolog and Lisp. So if someone enjoys those things, please talk to me, and we can talk about that. And thanks very much. If you have any questions, please go ahead now and connect with me, send me a message, and I would love to answer any of your questions offline as well. Thank you. No questions?
Yeah, when you say one of your slides, our cloud, what do you mean with our cloud? Do you have your own data centers or do you use other clouds too?
Say it once again, sorry.
When you said our cloud, I mean your cloud.
Oh, no. By our cloud, I meant, well, in our case right now, it's actually OVH cloud, but it's still a cloud, one of the cloud providers. I guess what I meant there is that for some clients, for some funds, it turned out it was completely okay if we just manage everything within our environment and we just set up secure networking with their environment, and that's it. With other clients, they are more sensitive about the data, so we actually run the whole system within their cloud ecosystem.
Premises, right? I mean, most of the companies, they want to have it on premises because of the security around it?
Like 50-50. 50-50, yeah. It depends, because also there are some other things that we're doing, but for example, with a lot of agents that work with data, we actually don't get any data to our servers in that setup. So we run most of the system on our premise, and then part of the system, like small, I want to use the word agent, but let's call it daemons, a small daemon within their system. And then we can just keep all the sensitive data on their side and most of the data on our side. But yeah, it's like 50-50. And to be fair, in that case, when that split setup is needed, it's just sometimes easier to deploy everything on their side and just deal with it all together.
We have a question from the online audience.
Oh, hi there.
How much does compliance in enterprise slow you down in deploying solutions?
Yeah. Well, that was dramatic. Yes. It's actually a very good question, because the answer is it slowed us down a bit, which is not an answer, I guess. With our largest client, we went through entire compliance process on their side. So I guess in terms of compliance, as in going through compliance process with the client, making sure that they can procure us and doing all of those things. With the largest client that we have, we went through entire process in 2 weeks. With most of our clients, I think the average would be around 2 months. So yes, it's not immediate. For the ones where we need to deploy stuff on-prem, it's a bit longer. So that's what pushes the time up. But I think generally, what I found is that in this industry, in finance, things are moving much faster than where I used to work before. So I used to work in healthcare before. In healthcare, this timeline would be impossible. Definitely 2 weeks would be impossible, and even 2 months would be a very, very good time.
Any other questions in the room? Anything else online? Awesome. In that case, thanks again, Ivan, for that fantastic presentation.
Thank you. Thank you.
I'll quickly jump into a quick introduction of what product management is all about. So if you have been associated with a product management organization, either in a developer role or as a product manager role, you would understand that as a product manager, you would need to do a lot of innovation. So if there's a business process that's not functioning efficiently, as a product manager, you're expected to solve that through some sort of innovation, through tech augmentation into your development processes or business process. So innovation is one of the key areas where you need to really invest a lot of effort as a product manager so that your organization can extract more value from their digital products. So with innovation, we are basically trying to fill the gap through technology. The second part is, if you are in a PM organization, you would expect to invest a lot of time collaborating with people within your product teams and external to your product teams. So 50% of my daily time gets invested is speaking to sales team, my project teams, my clients, and because I work for a B2B organization, we basically collect our requirements from the customer and make it standard onto our product. And that's the second thing that you would have to do as a product manager. And the third and the most important thing is, most people get wrong that through product management, we want to extract value from our consumers, but it's really the opposite. We want to create some sort of value for our consumers that are using our product so that they can feel or understand where the value in their business comes from by using our product. So let's say you have a product that you are selling to your consumer for £1,000 a month, but it ends up generating less than £1,000 for your consumers. It's really not the nice product you should be selling in the market. So at least having those asymmetric returns for your consumers, that should be the aim for your product management teams. So how do you actually come up with something in product management when you are doing new product development? How do you actually come up with an idea? So you would have an overarching business case that you would need to satisfy, and as part of that overarching business case, you would augment that with a business strategy which supports your product strategy. And I'll simplify that a little bit. So let's say you've got a business that's running smoothly, but then your CEO comes and says, I want 25% increase in customer retention or 25% decrease in customer acquisition cost. Now this becomes your overarching business objective. And how do you supplement or make this business objective happen is by delivering some sort of a product feature that can support that business objective. So on the top level, you would always drive any product initiative through your business or product strategy. And that brings me to one of the famous concepts in modern product development, which is utilizing product-led growth in your product management journey. So what product-led growth essentially means is you want to create a product that sells itself. You do not want to activate another sales channel in your organization and start to invest more money into selling your product and pushing your product into the market. You want to create some sort of a product that sells itself. And the classic example is something like a Midjourney or a ChatGPT, because the feature set or the value it delivers far surpasses the cost or the sales that you would do externally to your product. So you want your product to sell itself. The second thing is you want to deliver some sort of a eureka moment on your product, which means when Instagram Reels came into picture, everybody started to use it. It was all organic, word of mouth marketing. Nobody had to go and tell people, hey, there's a new feature, start using it. There was this initial eureka moment that you experience when you are following product-led growth principles while developing a product. And that's something that you should strive for when you are creating a product that follows this principle. The third one is you have to focus more on value creation as opposed to value extraction. And what I mean by value creation is you're delivering something to the consumers that asymmetrically surpasses the amount of investment that they are making acquiring your product. So this could be either a SaaS organization that's using your product as part of a subscription model, or a big enterprise consumer that are using your product as a customer relationship management or sales channel activation. You want to deliver more value as opposed to what your consumers are paying against that. And the fourth one, and the fourth principle for product-led growth is you want to generate some sort of virality into your product. And by virality, I mean you've got something into your product that immediately clicks with your users and everybody start to share the post, speak about it, and then share in their sales channel as well. And one of the other example that we all are looking right now is Sora AI that has just come into the market. Everybody's talking about it. You can create fantastic videos through Sora, and that's how you end up achieving that virality through your product. So this is just 4 overarching principles of product-led growth if you are building anything. And how this is relevant in the AI world, we'll explore a little bit later. So the next section is, you are sitting in a product development team and you have a roadmap that you want to deliver, but then you cannot deliver this roadmap with a fixed mindset, which means you cannot fix on a roadmap 3 months ahead and then try to correct that roadmap after everything is delivered and nobody wants to acquire your product. So having that agile mindset really clicks for a lot of users. And agile is not just about following a set of processes or principles, running your daily scrums, changing your user stories. It is more about the mindset that you inculcate within your product teams. And that's where the concept or a very famous iceberg metaphor comes into picture. So over the top, you see first thing is doing agile, which is you follow a set of practices. You are more focused on user-centric or outcome-oriented organization as opposed to inculcating your teams or making your team feel empowered so that they can fail and fail fast with confidence. So the transition from doing Agile to being Agile takes time, and it's a journey that you would take with your software engineers, with your testers, if you are sitting high up the value chain, speaking to your stakeholders, and this makes things much easier when you have initially coached all the people that you are working for your product. So now the next section we'll be talking about, we have looked at what product management is all about, what Agile mindset is all about, but how does this new AI era or AI trend support all of these activities that we just looked at? So if we just go back and rewind the clock 2 years ago, we had virtually a Jira, a Confluence, or maybe a product board to support our product management journey. And then you would have to really look at inputs, generate insights, look at foresight, and speak to a lot of people in the organization to actually come up with ideas to develop your product, either if you're in a growth phase or you're just building out your MVP. But right now, your product management lifecycle is completely transformed. So if you have a product that is in its early stages of development, you will go through these 5 development life cycles. So you would definitely do some sort of ideation, market research, define a concept, maybe come up with a proof of concept and deliver your first MVP. This process without AI augmentation would easily take you 6 to 12 months. But with all of these AI tools that are now available in the market, Fifth Row for ideation, Genie for market research, and UiZard that I really love to create prototypes, you can really squeeze all of this MVP definition in less than a month. Now, what this does for you as a product manager, it helps you validate your product faster, collect the feedback from your users much faster, and if you're failing, you can fail fast. You invest less money, you invest less time of your leadership convincing them why they should build this product or a feature that you have now proposed them. So it makes your senior level conversations easier while also enabling you with fast validation. So this is the kind of AI augmented product development lifecycle if you are in early stage of product development. But let's say you work for a company like a Microsoft that has already developed a Microsoft Teams that's been in the market for years and years. For that kind of a product, you would definitely need to use a late stage augmentation of AI tools into your product management journey. You would do a lot of development, testing and integration work, and then the major focus for your product once it has achieved a certain level of maturity is to achieve that growth. And for that, you've got another set of fantastic AI tools that you can now augment into your product development lifecycle and then make it much faster for your users. Just a very interesting insight I was just reading just 2 days ago. GitHub Copilot has significantly reduced the development time by 55%. So imagine and expand that into an organization that has got upwards of 10,000 developers. You're essentially saying you could now achieve the same level of output faster and with half the workforce. And that's the kind of transition we are seeing in the product management journey going forward. So if you'd like to take a picture, I would very much encourage to do that. And so this is the early stage, and then we'll move to the next late stage product development. You can start to read about it in your own time as well. And now obviously we've spoke about all of these life cycle stages, but these AI tools are not mature at every stage of your product development life cycle. There is a learning curve in these tools. There's a learning curve about how much history these tools have got available from which they can learn from and what kind of output they can produce. So the level of maturity decreases as your products or your product lifecycle stages moves from more probabilistic to more deterministic or creative. And that's why your ideation, market research, development and testing activities have achieved higher level of maturity through AI products, because they are supported by history. They could scrape through billions of parameters that are available and then provide you an output. But when it comes to more creative work, that is concept definition or an MVP definition, where you require a real human to speak to a lot of other people to actually come up with a product concept, these products are not as mature as you would like them to be. So that like summarizes the current space of maturity of these products. And then the most interesting part that you can now take away from this session is, let's say you are building your own SaaS product, or you want to build your own module within your existing product and you want to do it fast. How do you do it? And that's where the concept of product prototyping using AI tools comes into picture. And this is just a very quick schematic, and I see a lot of people confusing what a wireframe, mockup or a prototype means, and I thought I'll just clarify this before we move into that AI augmented prototype creation. So a wireframe is something which is low fidelity, it's in form of a sketch, it's a minimalistic drawing, you cannot click on it, it doesn't provide your user with the experience of your product. When you transform it into a mockup, it is medium fidelity, it has got graphics, your users can feel the product. And then when you talk about prototype, it's mostly either the MVP of your product or an MVP -1 of your product. Your users can interact with it, click on it, and then see how the successive screens of your product are going to look like. So in just very short single liner, a wireframe is something called a sketch, you cannot click on it. A mockup is a digital version of a sketch, you still cannot click on it, but a prototype is a working product that you can interact and click on it, and then you can also collect user feedback. And if you are building a SaaS product or any sort of a module in your product, you still have to do 1 or 2 versions of wireframe, 2 to 3 versions of mockup, maybe up to 5 versions of prototype development before you can actually release an MVP. But this was a study conducted by McKinsey back in 2023, and this is the kind of journey every product teams have to take to release their first version of MVP. So if you don't have an AI tool supporting each and every stages of your MVP development, you can easily cross 6 to 12 months into releasing your first MVP. You would invest 2 to 3 months generating insights and listening to users, what works and what doesn't. But if you have got that AI augmentation, you can basically reduce the time to market by a significant factor. I've personally developed an MVP myself in less than 20 days. And I'll show you how I've done it. And that brings me to a framework that you can take away from today's session. And I'm going to be introducing to you 3 powerful tools that you can use to augment your product development process. So first one is something called a V0 by Vercel. It is basically a developer platform where you can generate UI components through boilerplate templates. You can just write prompts and then it is going to give you an interactive UI component. Vercel is very powerful because you can also deploy your product by just 1 click. Then you've got something called a Cursor AI. Cursor is your AI powered code editor. So now your software developer roles are transforming into a software composer role where you can just write a prompt and then Cursor is going to do 90 to 95% of the coding for you. You might still need a principal software developer when things go south, but if you are looking to develop something that is more for customer validation or just to test your product in the market, I think it's a very powerful tool that you can use. And the third one is, we all know Claude AI, it's fantastic for writing code, refining code and optimizing code. And how I like to call it is Claude is basically ChatGPT on steroids. It does everything all by its own. With the new 3.5 Sonnet model, the power has tremendously increased. If you start to explore on the HiQ model as well, this is still powerful in your product management journey. So this is the kind of framework that you can use to develop your own SaaS product if you'd like to do that. And now I'm going to walk you through a live example. So remember I just displayed a tool called V0 for developing rapid prototype of your product. And this is the kind of design or an interactive UI that I created through V0. So what I'm saying to V0 is, please generate a UI for my generative AI chatbot where users can take input and the users can see a contextualized output. I'm just giving it a chain of thought prompt where I'm saying, okay, name the chatbot as chatterbox. Here is my input parameter. Here are my output parameters on my chatbot. You can use blue themes, etc. And this is the output it generated. I think if you know the chain of thought prompting and if you really know what you're building in your product, this is a 2 minutes job. You can actually type your name, phone number, click on that green button down there and see how the screen is going to transform into your actual product. And so I gathered interest in developing a chatbot and I said, okay, maybe I want to plan successive screens for a financial application. I want to see how my financial metrics look like once I am getting my users on board the platform. And these are the other screens that I could create right from V0. So once I've given it my names and details and I told him, or maybe it, that I want to create a financial application. It should have some sort of balance mechanism that users can see and feel, and then you could also project some sort of a monthly growth chart onto my chatbot itself, and it created all of that all by itself without any further prompting. If you look at overview, income, expenses, these are all clickable. If you just click on it, it's going to refresh a new screen and you could really see your prototype functioning on the platform. So this is the kind of power that you now have to immediately validate any of your product. This is a very simplistic example, but if you want to go complex, I would say you could end up designing something like a Facebook or a Netflix in 2 days' time if you understand the process in and out. It's all about setting the right media, setting the right tone, getting the deployment correct, and then you will have a working product. Now, the most interesting part, which is money. So if you are aspiring to become an AI product manager, I just did some quick Google search and here are some metrics that I have available for you. So worldwide, the number of jobs in AI product management have increased by 53%. The average salaries, if you are a bottom 10% PM, are at least $18,000 higher than your traditional PM. If the gap further widens as you move up the ladder as well. So it is going to be a really interesting and fast-paced space where you want to explore your new career options. The skill set is there, not a lot of people know how to use it. And we are all like pretty much in the beginning era. So nobody is behind, nobody is ahead. All of us can start on it and then really try to build our own product prototypes. And here are some people that I follow very closely in the product space, and we can just look at what they are saying about how this space is evolving going forward. So Shreyas, Akash, Sam and Sachin, they're all like very established people in the product space. They also run their product management courses. So if you'd like to explore, you can go ahead and search about them. But what they're saying essentially is product managers will become prompt managers over time. Hard skills will remain, but AI agents will supplement your hard skills. Business sense, analytical mindset, and communication skills will require acceleration in your product management journey. And then because everything is going to become easier and you can develop things faster, so insulation to over-engineering will be required. And that's it. That's my talk for today, and thank you very much. If you have any questions, I'll take them now. Yep. Yeah. So first of all, thank you for asking that question. So V0 is a developer platform, which means you prompt, it gives you the UI for your product. The backend of your UI is obviously a code that's either generated on Next.js or HTML or PHP, whichever language you choose. On the platform itself, once you prompt, it is going to show you the front-end UI, and once you flip the tab, you can also get access to the code base as well. So you can extract that code base, and then if you want to refine that code base even further, if you're building a big product, you can extract that code base, put that code onto cursor, and then try to refine it even further. If you want to deploy it, deploy your application, you can deploy it directly on V0. Somebody has to write still has to write the APIs for you so that your front end and your back end can communicate. But if you've got access to Replit, etc., that work is also becoming more streamlined right now. So essentially V0 does everything minus one, the deployment and database.
Is it free or is it?
It's free for the first 10 prompts every day. After that, you have to spend 19.9 in a month.
Any other questions from the room?
Yep.
First, thanks for the talk. That was very interesting. The one thing about V0, by the way, I think they do support full stack now.
Now,
So
okay,
actually,
perfect.
Yeah, you can do the whole thing there.
Perfect.
I was wondering, a big part of PM job is, of course, prioritization, doing all those things related to managing the work and managing the priorities and managing the objectives. And there are many ways you can do it using AI tools. There are some tools that you mentioned in your talk, but also just a bit of background. So my background actually is in product management before I started doing what I'm doing now. I'm using a lot of Claude right now, where I just load up everything in a project in Claude and just use that as my knowledge base, where I try to get some prioritization done. The problem is, of course, it's not really integrated with my product management tools. And none of those so far I found to have a good full stack of prioritization, breaking down tasks into smaller tasks, managing the tasks altogether. Do you know any better approach to try to manage everything together and connect everything
Now,
together?
I think you're absolutely right, and that's why I had another slide which showed you the maturity model as well. So we've got these stages in the product management lifecycle, and these products are not mature for every stage, which means if you want to do things in isolation for one stage, they function very well. I think product board is integrating a lot of stuff. So maybe not this year, maybe not the middle of next year, but by the end of next year, you would see more augmentation in product board. So that way you can achieve integration through your Jira, Confluence, or your prioritization. You can also incorporate user feedback and then try to identify patterns right on product board. But I think there is another tool that you can do that if you set that exceptionally well, which is called Notion. So you might want to explore Notion, but I don't think they are there yet. You really have to put your brains in the management of it, and these tools are exploratory, so the level of maturity is going to come. But yeah, I think in a year's time, we will not have a 20 people product teams managing all of the work. You will have smaller squads that will be product operators all of their own. So we'll move from people who are managing other people to product managers actually becoming an agency of their own, where they can support multiple stages of product development. So maybe in a year's time, your question might be answered, not today.
Okay, makes sense. Yeah, I don't want product people to just move things around. I want them to focus actually on the
Perfect.
interesting part of the job.
Yeah.
Thanks.
Any other questions from the room? Anything else, Ruth? Awesome.
Okay.
Thanks again, Sapnil.
Thank you very much. Thank you.
So hello everyone, my name is Artur. I'm currently head of R&D at GetMirai. We're a small startup building fastest LLM inference for mobile devices. And I previously was a machine learning engineer at Snapchat, and I was working on the object tracking team. So my talk will be about how to manage data in machine learning projects, and how to manage the complexity. And this will be a fictional case study based on a real project. Unfortunately, I cannot share real project details, but this will be very close to reality. Just all the characters and the application domain will be different. So let's consider a typical ML project. And for example, let's say we are building an application that generates 3D avatars for your cat. So it takes a video of your cat as an input, and it produces camera poses, 3D mesh, textures, normals, all the stuff that you can then put into a 3D rendering pipeline to generate a 3D image. Okay. And how do you start with such a project? Well, typically you start with some academic data sets. Let's say there is some OpenCats 3D data set. And you write a data loader for your training pipeline. And then you train your baseline model. And then you evaluate it. And you see that the baseline performs poorly on your data because, well, it's an academic data set. It's not supposed to be production quality. So you need to get some better data. So what do you do? Well, obviously, you hire some cats for motion capture, okay? And you collect the data sets with a mocap rig with all the, their joint positions and, 3D coordinates and camera positions and so on. And you write some code for pre-processing of this data to get a final data set. And of course, the data contains data samples of the different modalities than you previously worked on. So you write a new data loader for your training pipeline, train a new model, right? But the model you get is still not perfect because you're collecting data from cats and a mocap rig, and you only have sparse points, and maybe you need dense depth for each part of the cat. So what do? Well, you want to get a better ground truth. So you hire 3D artists to render cats in Blender and get a synthetic data set. And because you, again, have very different modalities, very different data format and so on, you have to write a new data loader for your training pipeline, and you have to train a new model. And to train this model, it works much better because you have much richer data, but it only works in daylight because, synthetic data is a symmetrical gap and so on. So what do you need? You need more diverse data. And hopefully you have already deployed your app in production, so you have some users. So you collect data from users, and you send it to contractors for labeling. And if you're in this industry for long enough, you know that contractors are never, they never follow instructions perfectly. So you have to do some clever filtering and aggregation and so on. So you write a pre-processing script, and you once again write a new data loader for your training pipeline, and a training new model on all the collection data. And you're ready to evaluate it, but some user files a GDPR request to delete their stuff, and you have never thought about it when you started this project, so you have no way to track the source of each image. So if you want to stay GDPR compliant, the only thing you can do is basically delete all the data that you have collected. Not good. So to summarize how the status quo of a typical machine learning project of such scale look like is, you probably have everything stored on a shared file system somewhere. You have each data set in its own format, which is the same format it came with. And images are probably stored as PNG or JPEG files, which have different read times. And you probably store annotations camera information, key point locations, and so on, as JSONs or CSVs, or JSONs inside CSVs, or some other crazy combination. And the rest documentation, it's a single page on Google Docs, and link to it is in someone's Slack DMs. Nobody, of course, is going to find it. And of course, you have fields like image shape is you have fields like image shape as 2 numbers, and it's not clear which of them is height and which of them is width. Apparently, it depends on the data sets. It can be either. And everyone who builds a new pipeline copies the same code for someone's Jupyter notebook. And there are, of course, bugs everywhere. And this is how it is in very many projects. And of course, there are performance problems coming with this approach, because if you're training small models, you are often getting I/O throughput limited, because your GPUs are crunching numbers much faster than you're able to feed them. And if you have different storage formats, you have inconsistent performance. And because you have so many data sets from different sources, you have humongous amounts of data loading code, which is very hard to refactor, and it's very hard to do performance optimizations. It's very hard to transfer one performance optimization from one pipeline to a different pipeline. And you cannot easily switch to different storage because you have to dig through all this mess. So it hurts. And the question is, can we do better? Well, obviously we can, and let's start with the setup. So, as I said, we're building a complex computer vision system, and we probably have multiple pipelines maintained by different teams. We have training pipeline, we have evaluation pipeline. I'll probably have some intermediate stages like, bundle adjustment and so on for camera calibration. And data is, of course, key. And we have various data sources. Like we have academic data sets, we have some capturing, synthetic pipelines, user data, et cetera, et cetera. And each of those data sets contains different modalities. We have RGB images, we have segmentation masks, meshes, whatever. And even more so, different data sets contain different subsets of those modalities. For example, like user data may not contain depth maps, but it can contain like joint locations labeled by humans. And some data sets contain still frames, some data sets contain images. And some data sets can even contain images captured from different images of the same scene captured from different cameras simultaneously. And what are the access requirements? Well, they are actually very different for different pipelines. Because, for example, random access is often required on per image level, because if you're training your neural network in a way that requires sampling different data sets, sampling samples from different data sets with different frequencies, you cannot just concatenate them into a single blob and just stream them sequentially. You have to randomly sample with weights. Also, you might want to train some models which operate on videos and some models which operate on individual frames, which also require different ways to slice data. And for training, the main requirement is high throughput. You don't care about latency. You're not serving some user-facing app. You only care about the ability to put as much images per second through the pipeline as possible. And there are also other requirements. For example, you want your data to be always consistent. So it should be impossible for someone to mistakenly write image dimensions in the wrong order, or write an incorrect image intrinsics, or to mix up measurement units when talking about like space coordinates. There should be documentation, there should be API stability, and there should be an ease of onboarding. So it should be easy to explain to a new person how everything works. And the last requirement, which is really nice to have, is the ease of use from a Jupyter notebook, because you want to be able to quickly look at the data and do some, a quick visualization and analysis from inside notebook without having to write lots of code. So the proposed solution is what I call data as API, which is opposite to what's commonly used, which I call data as files. And the idea is that the data is exposed through a strongly typed Pythonic interface, and the underlying storage is completely hidden from the user. So how it looks from the user perspective. Let's call our system cat data store. So from the user perspective, what they do is they import a Python library and create an object with using the name of the data set. Then they have those magic accessors that give direct interface to the underlying data in form of Python data classes. And heavy things like images and segmentation asks and so on are lazily loaded when you access the corresponding property. And there are tons of magical methods that automate what people typically want to do. For example, like compute projection matrix from the intrinsic parameters. And the same data contains multiple views because you may want for different, for example, when you're training a model that operates on videos, you want access to videos. But if you are training a model that operates on individual images, you only care about individual images. So you have different views to the same data, which provide you different granularity. One of the main ideas is to make invalid states unrepresentable. So most data constraints are encoded as types, and consistency checks are enforced via validators. So it is completely impossible to even create a sample which violates constraints. For example, it's completely impossible to create a set of frames, of a set of annotations describing views of the same scene such that 3D points don't project correctly to 2D points. This is checked when you try to insert data into the database. And there is documentation. And because it's a Python library, documentation is just basically a set of doc strings in Python files. So it's always part of the code. So when you edit the code, you edit the documentation. And it's easy to check that everything stays consistent. And it's directly available on tab in your IDE. So if you want to figure out whether something is measured in meters or in pixels or in centimeters or in feet, you just, in your IDE, you press tab and you see the doc string that says that, oh, it's in meters. And everything that should be, which may be ambiguous, like measurement units or array shapes and so on, is rigorously documented. So how does it work on the back end? Well, on a real project, what we initially started was to have a shared NFS drive which contains LMDB file for compressed arrays. So if you don't know what LMDB is, it's a memory map database, which uses basically operating system page cache as a cache, which means that if you frequently access the same images, they will be loaded and stored into RAM. And because of how page cache works, if you are accessing your data non-uniformly, the images that you access more frequently will be in the page cache, which is quite convenient. And we use SQLite for annotations. But the problem with SQLite in Python is that while SQLite itself is very fast, converting from relational structures to Python objects is very slow because Python itself is slow. So if you try to go to run queries into SQLite every time you need to load a new annotation, it becomes very slow in terms of throughput. So what we do is actually pretty neat. We start by accessing annotations directly by running queries into SQLite. But when we open the dataset, we start a background thread, which in the background loads everything from database to memory as a set of Python objects. And when the process finished, we just swap to in-memory version. So what it gives us is, if you're trying to just look at the data inside of a Jupyter notebook, you don't have to wait for a cell to finish because it's annoying when the data sets are large, and it gives you immediate results. But if you are doing some bad jobs on start a training pipeline, you get very high throughput after a warm-up period when everything is in memory. And we do tensor compression by default. So when training machine learning models, you probably don't want to use JPEGs because JPEG induces specific biases into the model that, it may not work as well on non-JPEG images. But you want to compress data, first of all, because on NFS, compression actually gives you a better throughput. And also for objects like segmentation masks or depth maps, it doesn't make sense to store them uncompressed because they are mostly like zeros and ones. So you need some compression. Apparently, the best trade-off between speed and between speed and size is given by LZ4 algorithm, which is not specialized for images, but it performs very well, and it's super fast. And if you compress all tensor data by default, you don't need to do things like run length encoding for your segmentation masks, and you don't have to manually encode and decode stuff. It just, the underlying library does this for you automatically. But there are some initial problems. Some of them are conceptual, as initial migration is very tricky because you have to dig through all this pile of unstructured data that you started with. And adding new fields requires careful thought, because if you have this unstructured file, you just add the new field into JSON and everyone has to deal with it. But if you have this API, you have to think about it as, you have to think about backwards compatibility and so on. And of course, if you provide libraries as a Python API, then C++ people will suffer. But that's basically their job. And you kind of can make them happy by providing a CLI interface. But there are some technical problems, which is NFS throughput is limited. And if you run multiple experiments concurrently, you're starting to exhaust the throughput of an NFS, and you again starting to be IO limited. And also, because we're loading annotations in memory, and Python doesn't have, well, didn't have until very recently, proper multi-threading. Each process has to have its own copy of annotations, which if you have very large machine with like 96 processors and 96 processes, this quickly becomes a problem. So we made a version 2, which kind of solves most of this. So we switched from Google Cloud Storage, from NFS and LMDB to Google Cloud Storage. And while Google Cloud Storage has very poor latency, actually it has basically infinite throughput if you have enough readers. So if you have a distributed training pipeline where you have multiple machines doing data loading and reading, the Google Cloud Storage scales very well. And we wanted to use Google Cloud Postgres for annotations instead of SQLite, but InfoSec people basically came and said, no, you cannot use GCP Postgres for some reason they didn't explain. So we're still using SQLite for annotations, but we additionally have local Redis instances and in-memory annotation cache layer. And instead of loading everything into memory of a Python process, load it into Redis. And we have a custom, basically what's custom, very lightweight custom ORM on top of the Cutters library to load data from Redis. And because of how the data is laid out and because how fast Cutters is, it actually is much, much faster than when reading directly from SQLite. But then the question, why to store stuff in SQLite and load to Redis, whether you can just directly store everything the way you store it into Redis. So there is version 2.1, which completely removes SQLite and just stores annotation as message files, which are loaded directly into Redis when the dataset is opened. So what we have as a result, we have an API which is very pleasant to use. So you don't have to write data loaders manually. You just open a library and you get data for free. Data is always consistent because you're physically unable to write incorrect and inconsistent data into it. And it is extremely easy to onboard new people into the project because you don't have to explain them anything. You just give them a link to the library, and there is a documentation, and they just open the read the docs site, and everything is explained, and you don't have to ask anyone. And because of all those performance optimizations on the back end, it is very high throughput system. And most of the heavy, like complicated data loading code is shared between teams and pipelines. Because every performance optimization that you do on the cat data store side. And automatically every pipeline that uses this data benefits from it. Which is, I think, excellent set of results. And I think I want more people and more projects to adopt this approach and stop using piles of JSON files as a main data storage medium. So yeah, that's all of my talk. I think I finished a bit earlier. So Hugh, if we can do some QA session if we have time.
We can do some questions. But first of all, can we have a big hand for Artur for that awesome presentation?
Thank you.